Today we are going to discuss about the acetylide method, right? Under the organic conventions, right? Let's discuss how to use the acetylides, basically the sodium acetylides, right, to elongate your carbon chain by more than 1 minute, right? That is our discussion for today, right? අපි බලමු ළමයි කොහොමද the sodium acetylide වගේ compound එකක් use කරන්න කියලා ඔයගොල්ලෝගේ carbon chain එක elongate කරගන්න. Basically by more than 1 minute, right? Units එකකට වඩා වැඩි carbon සංඛ්‍යාවකින් carbon chain එක elongate කරන්න sodium acetylides use කරන හැටි තමයි අද අපි කතා කරන්න යන්නේ, right? Okay. First of all, let's discuss how to prepare these acetylides, right? How to prepare these acetylides. That is the first discussion before going to the conversions, right? Okay. So the sodium acetylides, right? The sodium acetylides can be produced with the use of terminal alkynes, right? First, you need to come up with these kind of terminal alkynes, right? For those, right, you can add some reagents like sodium O, the NaNH2, right? With these, you are able to come up with these acetylides. This is the sodium acetylide, right? So basically this hydrogen, which is referred to as a kind of acidic hydrogen, this acidic hydrogen will be replaced by the sodium cation, right? That is how a sodium acetylide is made, right? So basically, first of all, you have to come up with a terminal alkyne. So to a terminal alkyne, if you are to add sodium or NaNH2, you can come up with sodium acetylides, right? Any kind of a terminal alkyne can be used, right? So even this kind of a thing, right? This acidic hydrogen can be replaced by those sodium plus ions if you are to use some sodium or NaNH2 with this terminal alkyne, right? So the reagents to go with is sodium or the NaNH2, right? That is how we are to come up with sodium acetylide, right? Okay, this is kind of a terminal alkyne. You know, the terminal alkyne means those are the alkynes where you have a hydrogen connected to the sp carbon, means the terminal carbon which carries a triple bond, right? Such kind of things are referred to as terminal alkynes. So with terminal alkynes, you are able to produce sodium acetylides, right? The special thing here with the sodium acetylides is actually this acetylide part, this carbon chain, this part can be used as a good nucleophile, right? These are very good nucleophiles, right? So these are strong nucleophiles, means these can be used, basically these negative carbons can be used to attack the positive centers of carbon chains, right? Like aldehydes and ketones, in aldehydes and ketones, or even in alkyl halides, the carbons are positive. The carbon which is connected to the halide atom is positively charged, as well as in aldehydes and ketones. For those carbons, as those are positively charged, we can use these negatively charged carbons to attack them, right? So those are very good nucleophiles where you see the attacks towards those positively charged centers, right? Okay, let's discuss such kind of situation, right? So these sodium acetylides can be used to attack to those positively charged carbons. Let's see, right? So if you are to add this acetylide to an alkyl halide like this, right? If you are to add these so produce acetylides to alkyl halides, right? So let's see. You are to add this acetylide to this halide, right? This kind of alkyl halide, right? So you are adding so produce acetylide here, the C minus, right, to this alkyl halide. What will happen? This NaBr molecule releases, and this negatively charged carbon will attack to this positively charged carbon, right? Because of this polarity of this bond, this is positively charged. So this negatively charged carbon will attack and connect with this positively charged carbon, so that will come up with this kind of a molecule, which is actually with more than one carbon is added. So you can create this kind of carbon chains with more than one carbon added, right? With the use of sodium acetylides, right? With alkyl halides, right? See, even with aldehydes and ketones, still you can prepare carbon chains with more than one carbon is added, right? With the use of acetylides, right? So let's come up with this kind of molecule. If you are to think of this kind of aldehyde or a ketone, even with ketones, right? You can come up with these acetylides, right? So this is kind of acetylide we can use, right? This section is there, right? The sodium thing appears, right? So this could be anything, right? Any R group, right? So it could be anything, even like this. So if you add this thing to this aldehyde, these kind of aldehydes or ketones, in this case it's a ketone, you can do the same thing even with the aldehydes, right? What will happen? Basically, as we all know, this bond is polarized and this carbon is positively charged. So our negatively charged carbon in your acetylide will connect with this positively charged carbon, right? So that is what happens, right? These two get connected and the pi bond here will be the bond to break and sodium will connect to oxygen. Let's write that the final product then. So you have this positively charged carbon here, right? This is this carbon, right? This is your first carbon, right? To that, these two R groups are connected. I'll write these two like this, right? And you have the CO bond. It could be written like this. The phi bond is broken and the sodium is connected to here, right? So we can write it as O minus and then Na plus, right? So and this carbon from your acetylide get connected to this positively charged carbon like this, right? So you can see the production of a new molecule, right, which is with some greater number of carbons, right? So that is how an acetylide can be used to produce some carbon chains with greater number of carbons, right? So you can clearly see to this 3 carbon compound you have added some section with more than one carbon, right? So that is how the acetylide can be used to produce organic compounds where you can add with some more carbons added, right? So basically acetylide will be attacked by the alkyl halides and the ketones. The alkyl halides and the ketones can be attacked by these so formed acetylides, right? Okay, now with these theories, with these learnings, let's discuss how to use these kind of reactions to come up with some compounds with greater number of carbons in conversions, right? Let's discuss about that, right? Okay. Let's try to do this conversion, this kind of conversion with the use of the acetylide method, right? Let's see how the acetylides can be used to come up with this kind of a synthesis process, right? හරි අපි බලමු ළමයි මේ වගේ synthesis process එකකට කොහොමද acetylide method එක use කරන්න කියලා, right? Okay, the first thing to do is as we are with 3 carbon chain or as we are with 3 carbon blocks, right? As we are with 3 carbon blocks, first thing to do is actually we need to break the final compound into 3 carbon blocks. We need to break the final compound into 3 carbon blocks, right? So you can see only 3 carbons are appearing here. Even with this block, you are with 3 carbons, right? First thing to do is that in a synthesis, first we have to break the final compound into 3 carbon blocks, right? Why 3 carbon blocks? Because we are starting with 3 carbon compound, right? Okay, so actually this is the connectivity, right? This is the new bond which is formed when forming this carbon skeleton, right? So here we clearly see these two are the functional carbons which will get connected to come up with the new compound, right? When using the Acetylides technique to come up with compound with more carbons, right? Basically, the acetylides should be used with the alkyl halides or with the aldehydes or ketones, right? I am thinking of using the alkyl halide and the acetylide, those two guys, right, to come up with this compound, right? First of all, one carbon should came from, as we know, the one carbon should came from the acetylide and the other should came from the alkyl halide, right? First, let's try to identify the carbon, the functional carbon which was came from the acetylide. නම් අපි මුලින්ම acetylide technique මේ වැඩේට use කරන්න නිසා, right? අපි බලමු මුලින්ම ඔයාගේ මොන බ්ලොක් එකද acetylide ගෙන් හැදෙන්න ඕනේ කියලා. නැත්නම් මොන functional carbon මේ functional carbon නැත්නම් මේ functional carbon ද acetylide section එකක් විදිහට introduce කරන්න ඕනේ කියලා, right? That is our first thing to come up with here, right? In this case, we are going to use one section, one block coming from the acetylide and the other from the alkyl halide, right? Okay. ළම එතකොට බලන්න එකක් alkyl halide ගෙන් ආව කියලා අපිට assume කරන්න පුළුවන් එක section එකක් මේ දෙකෙන් අනිත් block එක අනිවාර්යෙන්ම sodium acetylide ගෙන් ආව කියලා අපිට හිතන්න පුළුවන්. අපි බලමු එහෙනම් මොන section එකද, right? Left hand corner එකේ තියෙන section එකද A block එකද නැත්නම් right hand block එකද acetylide ගෙන් ආව වෙන්න පුළුවන්, right? Let's see. When we are to consider this block, the left side block, right? You clearly see the functional carbon. The functional carbon is at the center. This is a situation where you see the functional carbon with this block, right? The functional carbon is actually a center carbon, right? But in this case, right, in this block, the 3 carbon block, right, your functional carbon is at the terminal position, right? So surely this should be the section which should come from the acetylide, right? Because we know in sodium acetylides like this, right? In sodium acetylides, right, the functional carbon, this is the functional carbon that should be at the right corner position of your chain, right? Because it is from the terminal alkynes, right? So basically in acetylides, right, the functionality is at the corner position, right? So in this sense, right, this should be the group coming from the acetylide, right? Because why? Because when considering these two blocks, this is the block which has a functional carbon at the corner position, right? So for an acetylide, it is a must, right? So this is, I consider this section came from the acetylide, sodium acetylide, right? And this section came from the alkyl halide, right? Okay. Then let's try to come up with the two major compounds, the alkyl halide and the acetylide, which is needed to prepare this compound, right? Which is needed to prepare this bond, right? Okay. I think you are remembered, right? That basically our first task is to, in this kind of a conversion, our first task is to come up with the correct carbon skeleton. That is what we are trying now, right? අපේ ළමයි ඔයා දන්නවා ඇති මේ වගේ ලොකු carbon skeleton එකක compound එකක් හදන්න තියෙද්දි අපි මුලින්ම කරන්නේ මොකද්ද? correct carbon skeleton එක හදාගන්න එක, right? ඊට පස්සේ තමයි අපි මේ functional carbons ලා වෙනස් කරන දේවල්, ඒ වගේම මේ functional groups හදාගන්න දේවල් කරන්නේ අන්තිමට, right? මුලින්ම අපි කරන්න ඕනේ මෙන්න මේ carbon skeleton එක හදාගන්න එක. මෙන්න මේ carbon skeleton එක හදාගන්න එක තමයි අපි මුලින්ම කරන්න ඕනේ. ඒකට තමයි අපි මේ acetylide method එක use කරන්න යන්නේ, right? හරි, එහෙනම් අපි මුලින්ම ළමයි බලමු මේ carbon skeleton එක හදාන්න responsible වෙන alkyl halide එක acetylide එකයි ලියා ගන්න, right? So let's try to come up with the alkyl halide first, because it is at the left side, right? Let's write the alkyl halide here, right? Okay. So it is like this. So I just come up with this carbon, which is the functional carbon, right? So we can write this section, right? This is your functional carbon, right? Carrying a Br, right? This is a functional carbon, right? Okay, for the alkyl halide, and you can clearly see you are with 2 R groups, right? The 2 CH3 groups as R groups, right? So I put like this, right? So as this carbon is lack of 4 bonds, remember in Grignard method also we had done the same thing, right? So as this carbon is with lack of 4 bonds, we have to put the hydrogens, right? So only with 3 bonds, so you have to come up with 1 hydrogen there. So this is your alkyl halide, which should be used to produce this carbon skeleton, right? Okay, then we'll come up with the acetylide, right? Let's try to write the acetylide here, right? So when writing the acetylide, right, this is your functional carbon. I'll write like this. So acetylide functionality, right? Acetylide functionality, one can write like this, right? This is acetylide functionality. This is the alkyl halide functionality. This is the acetylide functionality, right? So when writing the acetylide functionality, you have no choice, right? You have to come up with all these 2 carbons, right? acetylide functionality එක අඳිද්දී ඔයාලට choice එකක් නැහැ. ඔයාලට අනිවාර්යයෙන්ම terminal position එකේ terminal alkyne එකක් විදිහට අන්න ඒ විදිහට ඒ salt එකේ විදිහට ඔයාලට acetylide functionality එක bring කරන්න වෙනවා, right? හරි. එතකොට so that we have came up with 2 carbons here, 2 carbons. So only 1 carbon is restricted, right? So that should be your acetylide, right? මෙතන මේ acetylide functionality එක ලියද්දි ළමයි එතනින් carbons දෙන්නේක් represent වෙනවා. හරි. එතකොට ඒක නිසා ඔයාලට තව ඉතුරු වෙලා තියෙන එක carbon කියලා. මොකද මේ block එකේ තියෙන carbons 3 දෙනයි. acetylide functionality ලියද්දිම ඔයා carbon දෙන්නේක් represent වෙන නිසා ඔයාලට තව ලියන්න ඉතුරු වෙන්නේ එක කාබන් කෙනෙක් විතරයි, right? ඔයාලට මතකයිනේ අපි හැමදාම මේ groups වල නැත්නම් මේ sections වල තියෙන R sections විතරයි ලියන්නේ. මේවා ලියන්නේ නැහැ, right? අපි makeups වලට අහු වෙන්නේ නැහැ. මතකයිනේ? We are doing those makeups at the end of the synthesis process, right? Okay, so these 2 should be the major compounds to come up with the with this carbon skeleton, right? Okay, let's join these 2 guys, right, to come up with this correct skeleton, right? Let's try to join these 2 guys, right? Okay, let's join. So what will happen? Basically this Br and this sodium, those will leave and these 2 guys will get connected, right? So as this is your positive carbon and this is your negative carbon, these 2 will get connected by releasing the sodium and the bromine of these 2 compounds, right? Okay, let's connect the 2 accordingly. So basically when you are connecting the stuff, right, just come up with this carbon skeleton, right? Okay, look at the carbon skeleton and write the carbons accordingly, right? So you have this carbon, right? You have this functional carbon of alkyl halide. The 2 CH3 groups are connected to that, right? So the 2 CH3 groups, right? And you have a hydrogen 2 and right, this carbon is then connected to this carbon, right? The acetylide functional carbon, that is this, right? So that guy is connected to a triple bond and a carbon and a CH3 group, right? So that is the connectivity. So you see, ultimately we had came up with the correct carbon skeleton. අපි දන්නේම නැතු ළමයි correct carbon skeleton එක නිකම්ම අපිට හම්බ වුණා. ඉතින් ඔතනදී ළමයි විශේෂයෙන්ම අර මම හැමතිස්සෙම කියනවා the major thing here is all about the heart of the question, right? This is your heart of the question, right? If you are able to come up with this section, right, the question is almost done, right? දැන් අපිට තියෙන ළමයි ඊට පස්සේ පොඩි පොඩි මේකප්ස් ටිකක් කරගන්න. මේ මේකප්ස් එක අපිට පුළුවන් වෙයි මේ synthesis එක complete කරගන්න, right? So what are the makeups we have to come up with, right? Basically this carbon skeleton is done now, so our functionality is at the at this position, right? But when it comes to the final compound, where what we are looking at is the functionalities are at these 2 carbons, right? So we have to bring the functionality to here, right? So and we can then add some Br2s, right? If we are able to come up with the alkene here, we can add some Br2s to come up with the ultimate compound, right? Let's use the method to come up with the functionality to here, right? That is bringing the functionality to the center of the chain, right? So we can, for that we can use the HBr method or the H2 method, right? Let's come up with those, right? So for that you have to come through alkene, right? So the things will be like this then, right? Come up with the alkene, right? So for that we can add the barium sulfate quinoline, right, with the H2 palladium, right? Then this function can be brought to here, right? With the HBr or the H2O method, right? Let's come up with the HBr method, right? HBr method, right? So with the HBr, right, you can come up with this, right? Br comes here, some hydrogen is there, so functionally comes to the center of the carbon with this method, right? So we'll release some HBr to come up with the function to this section, right? To come up with the function to here, we can release some HBr, right? And the alcoholic KOH will do so that your functionality is at the position we expect it to be, right? So now we are happy, right? So very simple thing to do, that is just adding Br2, right? That will give you your compound, right? It could be the CCl4, right? So the things are done with this part, right? So we have to do a bit more things, right? So come up with these two guys, and that is very easy because we are with the same kind of carbon skeletons, right? So now we are to come up with these two things, right? So alkyl halide can be prepared very easily by just adding HBr, right? It will give you the function to the center, right? So to prepare this, first you have to come up with the terminal alkyne, right? Terminal alkyne, right? So we have to come up with the terminal alkyne to prepare this, right? So to terminal alkyne, if you add sodium or NaNH2, that will provide this, right? To a terminal alkyne, right? So our task is to come up with the terminal alkyne here, right? From starting from here, right? So the function at the corner position, double bond function, right? What we need is to convert that to a triple bond, right? How to do that, right? Basically, it is through a Br2 and a releasing of 2 HBr molecules, right? So first come up with the kind of Br2 addition, right? So that will give you kind of this Br2 addition. Then, right, by releasing 2 of HBr molecules, you will come up with here, right? To release HBr molecules, we use alcoholic KOH, right? So that is our conversion, right? පැහැදිලි නේ ළමයි අපිට ওই විදිහට ඉතා පහසුවෙන් ඇස්ලයිඩ් මෙතඩ් එකකින් කන්වර්ෂන් එකක් කරගන්න පුළුවන්. ඉතින් මෙතන ළමයි පොඩ්ඩක් අපි මේක තව පොඩ්ඩක් එක්සැමින් කරොත් ඔයාලට තීරුම් ගන්න ඕන කාරණේ තමයි දැන් මෙතනදී අපි 3 carbon blocks වලට right අපි මේ compound එක break කරගත්තට පස්සේ දැන් 6 carbon එක 3 carbon blocks වලට break කරගත්තට පස්සේ මෙතන වැදගත්ම කාරණේ තමයි ළමයි you should be able to right assign correctly that which section is came from the acetylide, right? ඒ කියන්නේ ළමයි acetylide ගෙන් හම්බ වෙන්නේ මේ sections දෙකෙන් මොකක්ද කියලා assign කරගන්න ඔයාලට පුළුවන් වෙන්න ඕනේ. අපි Grignard method එක කතා කරා එතනදී නම් ළමයි අපිට sections දෙකෙන් නැත්නම් මේ parts දෙකෙන් blocks දෙකෙන් කැමති block එකක් Grignard කියලා use කරන්න පුළුවන්කම තිබ්බා. එක block එකක් Grignard, the other block is came from a aldehyde or ketone. ඒක අපිට select කරන්න පුළුවන් වුණානේ. හැබැයි acetylide method එකේදී හොඳට තේරුම් ගන්න අපිට මේ blocks දෙකෙන් ඕන block එකක් acetylide කියලා assign කරන්න බෑ, right? Basically for kind of a block to be kind of acetylide section, right? Basically the functional carbon should be at the corner, right? Functional carbon corner එකේ තියෙන නම් විතරයි අපිට ඒ වගේ section එකක්, right? එයා acetylide ගෙන් ආවා කියලා concern කරන්න පුළුවන් වෙන්නේ. ඉතින් එතනදී අපිට මේ section එක අනිවාර්යයෙන් acetylide කියලා concern කරන්න වෙනවා. එහෙනම් අනිත් section එක තමයි right alkyl halide එකකින් එතන වාගේ aldehyde ketones වලින් හම්බ වෙන්න ඕනේ, right? ඉතින් ඒ විදිහට තමයි අපි acetylide section එක select කරේ, right? ඊට පස්සේ අපිට පැහැදිලිම acetylide group එක ලියාගන්න ඉතින් මේ විදිහටම ලියන්න ඕනේ, that is acetylide functionality, right? එතන කාබන් දෙන්නෙක් represent වුණා. ඊටු කාබන් විතරක් අපිට set කරගන්න පුළුවන්. ඒ වගේම when we are writing the alkyl halide functionality, the CBr, you have 2 R groups there. And as we are lack of 4 bonds, we have to come up with a hydrogen, right? ඉතින් ඔහොම තමයි වාගේ heart of the question අපි solve කරේ. ඊට පස්සේ simple things were done to come up with the makeups were done to come up with the final compound, right? So that is how we are supposed to use acetylide in a conversion, right? ඉතින් මම හිතනවා ළමයි අද ඕගොල්ලෝ acetylide molecule එක sodium acetylide ඒ ස්ට්‍රෝං නියුක්ලියෝෆයිල් එක කොහොමද කන්වර්ෂන් එකද යූස් වෙන්නේ කියන එක තේරුම් ගත්ත කියලා මේ අපේ කන්වර්ෂන් එකත් එක්ක.